공하
Okay, let's it's the soft, slow, the load, 50, 20, 100, 90, 40. So at the first, we know this part for this section, T is 50. For this part, T is 30. For this part, T is how much? 130. For this part is 40. So where is the danger section? It means this section is danger. Thomas is T R J. Yes, no. Or D. D is.
Actually, you need to break it.
Yeah.
And find the
Make a break. You can take this part and this part. It's okay. T Morgus. T Morgus. So you make a summation is wrong.
break it here.
Understand? So T is Newton meter,吧? The unit is Newton meter. Yes, sir. Newton meter times R half D 但是呢 is half pi half D for is the max 是说有 sigma T hidden 的 sigma T must be 0. Understand? So Sandy make 这个Do you understand it? Understand it? Okay.
This is the most dangerous part of the shaft.
Yeah.
This is the most dangerous part of the
At first, you have to find every section, the talk in every section. This section is 50, this section is 30, this section is 130, this section is 40. Then we know the dangerous section is this one because it's the maximum value. So then find the term x. Is the danger section. If you don't know the talk in this section, if you don't know all the section in every, where is the 90?
We proved it by
19 just talk. This is the internal force. You have to find the internal force by section of method. Where is 90? Where is 90? Make a cut. Make a cut. It's 40. Is 90. So assume the torque here. So T is 130. Where is 90? 90 is here. That's that. Is seen. Is similar to the suppose it's a X loading rod. Yes, if I ask you find the sigma max, how to find it? Yes. For this one, Fn is 100. For this one, Fn is here is Fn is 80. So sigma max if what's that? Same. Last lecture, we know how to find the shear stress in shaft. PPT transmit all the PPT to them. It's easy. In this way. How to go with it?
let's do it from here. From here.
What's the one?
But they have it last year.
They have it. No, it's okay.
But like you can share the screen with them. Which one? Here?
Yeah. Okay. Last lecture, we know how to find the shear stress for shaft. In shaft, we know how to find the shear stress. The formula is tau is T log J. Yes, sir. If you finished the homework, you know it. Today, we're going to study how to find the torque of a motor exerted on a shaft. Because in engineering practice, shaft always transmit power. Transmit power. 对吗？It's a motor. It's a motor. We know the power. Transmit the power to the pulley. Then the machine working. So we have to know the torque exerted by the motor. How to find the torque exerted by the motor? Because for given motor, there is some information tell you the power. How much is the power? Is for every motor. For given motor, we know the power. T is T times d theta dt. It belongs to physics. Is T omega 2 pi ft. T is the power, water, or weight pound per second. T is the torque. Omega is the angular velocity in radians per second. F is the frequency of the shaft. Power can also be termed in horsepower, where 1 horsepower is 550 feet-pound per second. And according to the formula, we can find T is the torque exerted by a motor. Suppose here is the example. A solid steel shaft is shown in the figure. It will be used transmitter 5 horsepower from the motor M, which is attached. If the shaft rotates at omega is 175 RPM, and the steel has an aluminum shear stress of aluminum stress is 14.5. Determine the required diameter of the shaft to the nearest 2 or 8 inch. At first, we know the power of the motor is 5 horsepower. It's not translated. We change the unit to feet-pound per second, because we know 1 horsepower. Here is 1 horsepower is 550 feet-pound per second. Yes, sir. So we know 5 horsepower is 5 times 550 is 2,750 feet-pound per second. Is the power. We know the angular velocity. We know the angular velocity. Is the angular velocity omega is it means 175 revolution per meter. Change the unit is 18.33 radians per second. Is easy. Then we will find, because the power is T times omega. We know power is T omega. That's right. So we can find T is 150.1 feet-pound. It means the motor exerts a moment, a torque on the shaft. The torque is 150.1 feet-pound. Because in engineering practice, shaft always transmit power. So we have to know the torque exerted by the motor. So after we know the torque, we know when we design a shaft, the mass must be equal, must be less than Arrhenius stress. Yes, because mass is TCG. Yes, TCG must be Arrhenius stress. It's T same is same. It means T allowable stress must less than GC. Yes or no? So when T allowable stress equal to GC, from the equation we can find the radius. The radius of a shaft. It means if the radius of the shaft is more than C, the shaft is safety. It means amount is less than Arrhenius stress. Answer. From the formula, we can determine the radius of a shaft. The formula comes from this formula. Understand? So let's design the shaft, the radius of the shaft, because T, we know T is 150.1 feet-pound. Apply the equation. We can J is half pi C to the fourth power. Over C is T Arrhenius stress. So from this formula, from the equation, we can find the C is. Yes, from this we can find yeah. So 你看 C from here, half pi C half pi to the fourth power divided by C equal T Arrhenius stress. Yes or no? How much is T? T is 100. 150. Yes or no? Change it into inch because it's feet, inch, and change the unit. Yes or no? T Arrhenius stress. Arrhenius stress is Arrhenius stress. Arrhenius stress is 14 pound per inch. 14 pound per inch. 14 大到5嘛。Yes. Yes. Find the 5. 100 10,000 because 1 KSI equal 1,000 pound per inch. Yes, is a unit. We have to know unit. 1 FT equal 12 inch. In this way, so we can find it's C to the fourth power. Half pi is half pi is pi to so we find the C to C to T pi over. In this way, we find the C is 0.429 inch. It means if the radius of the shaft is more than 0.429 inch, the shaft is safety. But if the shaft is the radius of the shaft is too large, waste material. How? So we have to find because in market, the shaft is made in because the shaft is in the shop. Is a shaft in the shop is one shaft is the smallest 1 inch is 2 inch 3 inch is not. In factory, a factory make a lot of shaft, is not, but the shaft is made of in this dimension. The smallest is 108 inch. Then that's that. Why? Because in this way, the shaft is cheaper. If the factory just make one shaft for you, then it's expensive. So he make a lot of shaft. Then when we use shaft, so because he 7/8 inch is 0.875 inch. Half of it is half of it is 0.437 is all is more than, yes or no? If you choose the shaft is inch, half d must be less than it. It's danger. So it's okay. If you choose the shaft is inch, waste material. That's that. So in this way, we can choose a suitable, yes, a suitable shaft. That's that. Okay. A tube shaft have an inner diameter of 30 millimeter and the outer diameter of 42 millimeter. Is to be used to transmit 90 kilowatt of power. Determine the frequency of rotation of the shaft so that the shear stress will not exceed 50 megapascal. Megapascal.
Megapascal.
Hey, stop working on the PP.
Why is it moving? I don't know. Eh?屏蔽。那真的呢？ You want to know what? You want to know what? I want to know. How to forbid it?
Oh my, how do I stop him from doing it?
How to stop it? Stop it in one.
Yeah.
这样子 ，Yeah， 这样子现在真的。Tubular shaft have an inner diameter of 30 millimeter and an outer diameter of 42 millimeter. It's to be used to transmit 90 kilowatt of power. Determines determine the frequency of rotation of the shaft so that the shear stress won't exceed 50 megapascal. At first, we know tau max is Tc over J. Yes, sir. Tau max is Tc over J is the formula. Yes, sir. Tc, the tau max is 50 megapascal. So 50 Newton per square meter is T. It's T. Because the diameter is 24 or 42. So radius is 21. Yes, radius is 21. So TC yes, over J 是 half pi. The outer radius to the fourth power minus the inner radius to the fourth power. It means the shaft is the whole shaft. Is the whole shaft. Is the whole shaft. Is the whole shaft. Yes, the distance is yes, the distance is so J 可以呢J is half pi C for out C in. Yes, sir. So we find the torque is 538 Newton meter.
Why we use outer C? Why not?
Because tau max happened on the surface of the shaft. You forget it now. C. Where is the tau max for shaft? For shaft, suppose the torque is T. Where is tau max? Tau max, you know, is TCJ. Yes or no? Where is the tau max? Yes, is the surface. So you have to use the radius. The distance is here. We know the distribution of the shear stress is in this case. That's it's tau max. It's tau max. If the distance from the point less than the radius, tau is less than tau max. We introduced in the last lecture. Yeah, the shear stress is proportional to the distance from the point to the center. Yes, not. So we can find the T. We can find the T is 538 Newton meter because the P from the formula power is T, E theta dt is T omega, it's total frequency T times T. T is torque, yes. Is tau, is tau, is torque, is shear stress. You forget it. 2 pi is the angle. 2 pi is the angle. F is the frequency of the shaft rotation or cycle per second. It means revolutions or cycle per second. So 2 pi f is the angle of the shaft when rotate an angle in a minute. Its density is the power. So we know, in this case, we know T, we know P, 90 kilo power, kilowatt. 1 watt is 1 newton meter. Yes or no? So is 90 times 1,000 equal to F density. So F is we can find the F is 26.6 revolutions per second. It's a hit. Answer that. So let's how to close it? Oh, I can close it. Oh. Okay. So here's some exam. Oh, okay. Wait. Oh, 怎么回事？Yeah, after where? After where? Share. This one. Okay. Look at the question. The gas attached to the fixed and the steel shaft are subjected to the torque. So if the shear modulus of elasticity is 100 gigapascal and the shaft has a diameter of 20 millimeter, the power transmitter is 17,000 Newton meter per second. The shaft turn friendly with the gas at B. Where is that? At B. Torque between AC. Torque between AC. We have found it. Oh, yeah, yeah. Then find it. Ah, yes, Justin. Yeah. The first answer is when is the torque between AC? Yeah. 150. Yeah. 150. Look at it. And then look at it. Here is the solution. Okay. Between AC is JFG is half pi C to the fourth power. Is easy. Torque 50. Torque between AC TAC is 100. TAC is minus 25. Answer is here. It means the sharpness is yes it's A, it's C, it's C, it's 280. It's 40. It's 40. How much is the torque? How much is the torque at point E? Because it's A and C cut it. Cut it. That's right. So we can find the TAC is 100 Newton meter. That's right. It's positive, not is a mistake. It's a positive 150. Yeah, it's a mistake. It's a mistake. Can find the talk between CD, talk between CD, talk between CD. How to find it? From the figure 150, 280 is tau CD, is TCD. So we can find the CD is actually is minus. Actually, let's find it. Make a cut 100 and 200 is a positive direction. It's a point out of the material is a positive direction. We'll find the T is minus. So is minus. So he find it is positive, is negative. And that sign conversion. If the thumb point out of the material is positive, point in the material is negative. Yeah. Is find the internal force. This problem. Break tender. Is it time for breaker? Oh, okay. the torque for AC, CD. We have to find the torque in section DE because the shaft is balanced. Suppose is T, yes or not? So 100 minus plus 40 plus T must equal 0. So T equal how much? Newton meter. 90.1.5。看看90。Really is 90。132.8，哎，is 90 really 90啊，is 90啊。Omega P equal T omega。The 40 is 40. Oh. Yes, I make this. Is negative. Yes, is yes, sir. Right, is. I make a mistake. Yes, is T is 170. Yes, so we know this question. We know this. F T, so we can find T omega is P over T. We find the angular velocity is 100 radians per second. Yes or no? Then after you find omega, then we can find the frequency. We can find the frequency. F omega equal 2 pi F. F is omega divided 2 pi. It's very easy. Yes, sir. Then we can find the frequency. After I introduce the power, the transmitted power of a shaft, then I will introduce how to find the deformation of a shaft. Because I didn't introduce how to find the angle of truss between CD, angle of truss between DE. I didn't introduce it. Yes, sir. So I will introduce it. 哎呀，怎么回事啊？ angle of thrust. Angle of thrust. Angle of thrust is the deformation of a shaft. We know gamma max is C phi over L. You remember it? So phi is phi. Phi is the relative rotation of these two ends. It's a relative rotation. So gamma max from Hooke's law is tau max over G. Hooke's law. Tau max is Tc over J. So we can find that. Gamma max CL phi is not from the two equation. We can find the phi is TL over GG. Let's derive it. Gamma max is a shell deformation. It's C phi L. Introduced it last lecture. Gamma max is tau max over J is Hooke's law. We learned it. It's tau max is TCJG. Yes, so they are equal. C phi L equal TCJG. It's not delete C, put L here. So we'll find the phi is TL over JG. It's not TL over JG. Yeah. G is a shear modulus of elasticity. Yeah, is a constant. You forget it? Oh no. So this is a deformation of a shaft. Suppose it's a general shaft. Every part have different section. The cross section, the area of cross section are different. The torque for every part are also different. How to find the relative rotation of the two ends? We can make a summation. It's okay. So it's the formula. So we can find it. We get the formula. Then let's continue the. Is this one? Yes. How to find the angle of thrust between AC? Try it. Yeah. We know how to find the torque. Yes or not? Then how to find the torque? How to find the deformation of the part of BC AC? The formula is TLJG. G is here. Diameters of elasticity. Yes, sir. Gigapascal. Phi AC is here. Yes, sir. Actually, FN data is positive. Is a positive 100 is a positive. So there is no negative sign. Yes, sir. Is 0.0382 radius. TLJG 150 Newton meter times the length is 0.4 meter over J. J is here, isn't it? J is here. G is here. 100 times 10 to the length power. We find the radius, the deformation. Understand? Just use the formula. No mass. Yeah, no mass. Yes. No mass. There is no mass. So we can find the deformation. Angle transfer between CD. How to find it? Angle of transfer between CD. How to find it? Yes. CD. The relative rotation between CD. You don't know? Oh. At first, you have to know the torque. How much is the torque? Minus what? 130, yeah. 130 minus. Yes, minus, yes. And is CD. CD, why CD? T is minus 130. Minus 130. You here lost the minus. Hence, length. The length is 0.3. Yeah. Break at here, find the internal force, find the torque. Torque is 130. Yeah, it's negative. Yeah, it's a negative one. Here is make a mistake. Yes. Because there is sign convention. divided the G funded. Is ingredients. The result from the formula is ingredients. Then determine is a hard one. Is a difficult one. Determine the total angle of thrust of the P on the gas. It means determine the total angle of the thrust of the P on the gas. It must be found phi DE plus phi CD plus phi AC. Some of them is negative, some of them is positive. So, can you? It's difficult. Phi what? Yeah, phi ED. You have to find ED angle transfer between DE. I write it. We know. TAC is how much is TAC? Talk between AC is 100, 150 positive. Yes or no? TCD is 130 minus. Okay, minus Newton meter. TDE is how much? TDE is minus. Is minus 吧? Yes or no? Is minus 吧? Number is minus. So phi AE. Yes or no? Phi AE equal 100 amps. Distance is JG minus distance is 0.3 JG minus 0.5 GG. GG is JG is here. J is here. G is here.
Okay, 1570.
Oh, one. I just tell you how to find it. How much is GG? Okay. Well, okay, you are. It's okay. Okay. Look at the answer. Phi. Look at that. Phi is sigma. Yes or no? Is actually, you may answer is a positive. Is a positive minus. Yes sir. You want to calculate that? Same must be same. I share this screen. I shared it. I shared it. You can't see it. I shared it. Hmm? I shared it. Shared it. Didn't I? It's here. Minus his sign convention different from. It's correct. Yes, sir. So we know it. Okay. Understand the problem. If you know all this question, you know how to find it. It means you know torsion. This chapter torsion, you grasp it. It means if you can solve every question, it means you understand torsion chapter. I didn't know. The exercise. Send it to you. Oh, okay. You can copy it from the PPT. You can copy it in the desk. A different homework too. How to solve this problem? There is a lot of problem. Yes. Problem question 4. Okay. Question 4. The 20 millimeter diameter A steel shaft is subject to torque. Determine the angle thrust of the end B. We can. How much is How much is G? G is 200 gigapascal maybe. And B. Let me. Yeah. Total torsion. Let me find the G. How much is G? Homework 2. G is. Well, G is 75. Yes, 75 G. 75 G gigapascal. Yes, gigapascal. Okay. This one. Share the. And you find it correctly. I'm waiting you. This one. G is 75 G part. You can, I suppose. You're tired. You try, okay. Linda, can you? Yes. Maybe. Just maybe. It's a fixed end. Yes, now ask you find the rotation of end B. It will rotate. Yes, this part is fixed. It will rotate an angle. Ask you find the angle.
So what I was asking is the limit.
Huh? End of B A.
That means the whole part.
Yeah. Well, when the 3D talk act on the shaft, the end will rotate. Yes, rotate. Ask you find the angle. The cross section will rotate.
Okay, but just
Yeah, it means find the angle between B and A. Between B relative to A. But A can't move because A is fixed.
there's no movement about it.
Also, there is movement, but it's fixed. Cross section of A can't rotate. It's fixed. Yeah. So just this part can. You can find the talk. It's easy. It's very easy lah. For the soft, it's how much? It's 8. Yes, now how much? It's 20. It's how much? 30. Is how much? Because the summation must be 0. So T is 90 嘛. Must be 90. Yes, no. Summation, all the talk must be 0. At first, you have to find the arc for each section. You don't know. C 20 millimeter 啦，20 millimeter you don't know C G is G is 75 G Pascal. You know? Negative. At first, cut it. So t is a minus 8. Yes or no? Is 8 嘛? This part. This part. T is 8. Minus 60. Yes or no? Is minus 60. It's why all these things are negative. Is minus 90. 怪事情。也是负的。它 all the talk for every section are negative. Is the minus. No, when you want to find the t, some point out of the cross section is a positive direction. Is a positive direction. So 8 minus equals 0. So find the t is a minus 60. Eight. It's 30 what? 30 is here. So that's okay. Look at when you want to find the internal force is 8. Is that I can write it of the t point out of is positive direction. I can write it is 0. Oh, then find the t is minus 8. I can write it is 0 and the t is minus 0. It's static stuff. What's that? When you get the equation, adjust from static stuff. You're confused. Yes, Sam. Yeah, is a positive direction. Yeah, is minus. Yes, is right now. Look at the answer. No, okay. Is 80. Or is 90? Is 90, but not 80. It's minus 80. Minus 90. 90 啊，90。You confuse me. Yeah. DA 吧，DA is minus 90 is right. Maybe is right. Maybe not right. Okay. I write it lo. Okay. Because it's minus 80. It's minus how much? 60 minus 90. Yes, sir. So phi B A equal 8 minus 8 times distance. G 75乘 G how much is G? Half pi C 10 to the 4. Yes, sir. Minus 60 600 yes, sir. Minus 90 distance half pi 10 minus 3 4. Yes, sir.
Solving for the tool.
Yeah.
Can I use clockwise and anti-clockwise?
When you want to find the torque, just find just from section of method. Just find the method. Suppose I want to find the CD, make a count. Assume it soon out of it, find out of assume it T. Then, according to statics, find it.
Yes. And also it's movement. So down is anti-clockwise.
It's dependent. It's determined by yourself.
So minus 80 plus 80.
Yeah, you can positive, negative, positive. You can write it. Yeah, you can also write it. Sin. Understand? Sin. Sin. Yeah, sin. Find the T is minus 60. Sin. Understand? But you have to assume it positive direction is mechanics of materials. The conversion, same conversion. You always assume it, point out of it. You didn't know what? It's 30. Look at the answer. Look at the answer. Okay. Is the answer? Yeah, is the answer. Yes or no? Minus 80, minus 60, minus 90. Sin. Is okay. Is not okay. Don't test me. Don't test.
The RAS to 5.7.
Huh? change what? 0 这个0 what 是什么呢 ？Rot radius 0.1 0.1这个啊
When you finish solving, then you leave.
yes can you needn't change it in degree. What's this? What's this?
Is the answer is what?
The answer for the
Your answer is here, is this?
Yeah.
But the answer is this. Your calculator is wrong. Your calculation is wrong.
Do you run wrong?
In radius.
Wrong.
Wrong. I didn't. Share the screen again. Sit down, please. Understand? You understand that? You understand? Sally, you didn't understand. Where is your problem? Huh? The number 30. 30. Where is 30? There is no 30. Oh, I didn't use it. It's yeah.
after you achieve, when you did the formula, you put the line that the distance of that one. So you added the 8 and the distance of that one. C'est ça la motion capable. Just to talk with the
Yeah. Yeah, just use the formula. Easy. You're very good. Okay. Homework. Yes. Homework. This one is your homework. Okay. That's all for today. Oh. Yeah.
Coming from class without know anything new, you don't eat.
Yeah.
Like in which situation are we supposed to use, like, for example, all the time? Because sometimes I used to remark when you used to do the correction.
Yeah, slowly, what's your problem?
No, sometimes when you want to use the formula,
Yeah.
you used to use only one term. And
Yeah.
sometimes you used to use every term. So me, I want to know when are we supposed to do that?
Section of method. selection of method 嘞，for soft 啊，so soft 是 T1 T2 T3 T4 yes or no make a cut if I choose the red part T4 T is T4 I can use this this part 那么 is T1 plus T plus T minus T2 plus T 哎，看 T1 T2 T3 is positive is negative must be 0 then find the T so I use lots of T just use one T if you choose this part to analysis there use this one understand sometimes I consider sometimes I consider red part sometimes I consider red the answer are the same okay all right Equilibrium. Yeah. Yeah. Yeah, equilibrium.
Oi, Phong Ha. Well. Emil. Emil. Oh, him.